Hello my dear students, welcome to the class of 11th English Medium. The subject is Statistics, Chapter 5, Skewness of Frequency Distribution, brought to you by Vitan Sir. In my last tutorial, we studied about what is skewness, what are the types of skewness, that is positive and negative skewness. Apart from that, we also studied about the methods of calculating skewness. There were two methods, Karl Pearson's method and Bowley's method. Now in this tutorial, I am going to study about Karl Pearson's method of calculating skewness. Now what Karl Pearson has done is that he has used the relationship between mean, median and mode to calculate the value of skewness. Now we know that if it is a symmetric distribution, the values of mean, median and mode will be equal. But if it is a positive skewness, mean will be greater than mode, and if it's a negative skewness, mode will be greater than mean, that is mean will be less than mode. Therefore, considering that concept in mind, the method of skewness by Karl Pearson is very simple, x bar minus mode. If the skewness is positive, then mean will be greater and our answer will be in positive. If skewness is negative, then mean will be less than mode and our answer will be negative. That means simply using x bar minus mo, we can get the type of skewness and their relationship. Sk here is the symbol of skewness, x bar is the mean of the distribution, and m0 or mo is the mode of the distribution. Now, in a case where we cannot calculate mode, there are certain cases, for example, bimodal classes or classes with unequal class lengths or classes with mode at the very beginning or at the very end. In those cases, we usually cannot calculate mode, and we know that at that time we use the empirical method of calculating mode, that is mode is equal to 3m minus 2x bar. So if we apply that empirical method into our calculation here, because we can't calculate mode, our method of skewness will be 3 times x bar minus m, and here m means median of the distribution. So in the case where we cannot calculate mode, then we can use median in the place of mode, but our formula will be 3 times the difference between mean and median. Okay, so if it is just mode, it is just x bar minus mode, but if it is median, it is 3 times the x bar minus median. So these are the two formulas or the variation of two formulas for Karl Pearson's skewness. But measure of skewness sk is just an absolute measure, and hence we cannot use it to compare with other data, and for that purpose we have the relative measure of skewness, which is as follows, that is relative skewness is depicted as j. Skewness is sk and relative skewness is just j, which is x bar minus mode upon s. But again, here J is the coefficient of skewness, so relative skewness is also known as coefficient of skewness. X bar we know is the mean of the distribution, mode is the MO is the mode of the distribution, and S is the standard deviation of the distribution. So for the calculation of relative skewness, we also need to calculate standard deviation. So we need to calculate mean, mode and standard deviation to calculate the coefficient of skewness. But again, in the case where mode cannot be calculated, our formula for skewness will be 3 x bar minus m upon s, where mode cannot be calculated. Okay, so only in the cases where we cannot calculate mode, we have to use this alternate formula, else we have to use the main formula, that is x bar minus mode upon s. Now, there are certain things which you need to remember in the case of Karl Pearson's skewness. Number one, practically the coefficient of skewness of Karl Pearson always lies between values -1 and +1 for a skewed distribution based on sample data. So value of coefficient of skewness is always between -1 and +1. If it is less than -1 or more than +1, then there must be some error in either a sample or in your calculation. Now if we are finding skewness for the distribution with multiple modes, or where median was used in place of mode, the alternate formula I'm talking about, for the calculating skewness, the coefficient of skewness lies between -3 and +3, because when we use median in place of mode, we use the formula 3 times mean minus median, so naturally the ranges become 3 times greater than usual. So the ranges here are -3 and +3 for the alternate formula. But in 1951, statistician N.L. Johnson proved that coefficient of skewness calculated using median in place of mode lies between root -3 and root +3. That is -1.73 and +1.73 for a unimodal frequency distribution. So these are also the ranges proved by N.L. Johnson for a unimodal frequency distribution. So for a distribution which only has one mode, but it is not possible to calculate it using our regular method, then the ranges will be -√3 to +√3, that is -1.73 to +1.73. These ranges mean that the value of coefficient of skewness will not go above or below these ranges, they will stay between these values. Now let me add one last point, that if your coefficient of skewness is 0, it means you have a symmetric data, there is no skewness in the data. If it is positive skewness, it will be above 0. If it is negative skewness, it will be below 0. But if it is 0, it means that the distribution is a symmetric distribution. Remember that. These ranges must be remembered, because any answer out of this range may be incorrect. Okay, so these are some important points in MCQs. This kind of questions, these kind of ranges have been asked many times, so remember them. Now let's start with some sums to understand this Karl-Pearson's coefficient of skewness method. I'm going to start with exercise 5.1. First question. The following distribution shows demand of 500 ml pouches of milk by 59 consumers. Find Karl-Pearson's coefficient of skewness for the data. Okay, so we need to calculate Karl-Pearson's coefficient of skewness for the data. Given data is demand of pouches 1, 2, 3, 4, 5, 6, 7, 8 and total. Now next is the number of consumers, that is frequency 2, 7, 10, 15, 12, 7, 4, 2 and total is 59 consumers. Now from the data you can see that mean is calculated as fx, frequency, into number of pouches, that is demand, that is x, and if we want to calculate mode, we need the maximum frequency, which is 15. So there is not an issue in calculating a mode. So we will write down the row of fx, where I am going to multiply demand with number of consumers, that is 1 2s are 2, 2 7s are 14, 3 10s are 30, 4 15s are 60, 5 12s are 60, 6 7s are 42, 7 4s are 28, 8 2s are 60, and the total is 252. So using this I can calculate mean. Now if I want to continue at this same thing, I am going to calculate fx square, because using fx square I can calculate standard deviation also, as in our question we have to calculate coefficient of the data, the skewness. We need mean, mode and standard deviation. So fx is for mean and fx square is for standard deviation. I suggest you guys that if you have not watched my third and fourth chapter videos, just go through them, because that way you will be clear about the many methods of calculating mean and standard deviation, which you will be able to use in this chapter. Okay, so starting with fx square. Now how to calculate fx square? Fx multiplied by x is demand, so fx values will be multiplied by with the demand values. So 2 1s are 2, 14 2s are 28, 30 3s are 90, 64s are 240, 65s are 300, 42 6s are 252, 28 7s are 196 and 16 8s are 128, and when you make a total you get 1236. Now we start with mean, which is summation fx upon n, which is 252 upon 59, that is 4.27 pouches of milk. So average demand of the pouches of milk is 4.27. Next, mode. Now mode is the observation with highest frequency. Here highest frequency is 15. So the observation with the highest frequency, which is 15, will be 4. So highest observation with highest frequency and the observation in front of it is 4. So mode will be 4. Next, I need to calculate standard deviation, which is summation fx square upon n minus x bar square. So summation fx square here is 1236 upon n is 59 and x bar is 4.27 square. So when I simplify this, I get 20.95 minus 18.23. Okay, and when I get a difference, it is 2.72 and the square root is 1.65 pouches. So the standard deviation for the data is 1.65. Next, I need to calculate coefficient of skewness, that is J, which is x bar minus mode upon standard deviation. 4.27 minus 4 upon 1.65, that is 0.27 upon 1.65, that is 0.16. So my dear students, your answer here is 0.16. Let's move on towards the next sum. Question number 2. The following distribution shows purchase of t-shirts by 270 consumers. We have to find Karl Pearson's coefficient of skewness and interpret it. Okay. Now the data given is shoulder length of the t-shirts in inches, that is 12.0, 12.5, 13.0, 13.5, 14, 14.5, 15, 15.5 and 16. Then the total. Now the frequency given, that is number of customers, are 5, 20, 30, 47, 56, 56, 37, 16, 3 and the total are 270 consumers. Now from the data you can see that if you need to calculate mean, because the shoulder lengths all are in equal distances, I'm going to convert them into D because I'm going to use the shortcut method here. If I want to calculate mode, then I need the highest frequency, but from the data you can see that the highest frequency is 56, which is appearing twice. That means this is a bimodal data and I can't calculate mode for a bimodal data, and therefore I can't use mode for calculating skewness. So in the place of mode I will be calculating median, and for calculating median I will be using the cumulative frequency column. So I need to prepare a cumulative frequency column afterwards. So the columns which I will be preparing here, first of all it will be the D column. The D here is D is equal to x minus 14 upon 0.5. The 14 is the middlemost value and 0.5 is the class difference between all the values here. So that way, if you do 12 minus 14 upon 0.5, you will get negative 4. 12.5 minus 14 upon 0.5 will be negative 3. 13 minus 14 upon 0.5 will be negative 2, and so on. So just keep on using these values. 14 minus 14 is 0, obviously. 14.5 minus 14 upon 0.5 is 1, and so on. You don't need to make a total of this row, but you need to calculate these values accurately for the future rows. Next, I'm going to calculate FD, because to calculate mean I need to multiply D with my frequencies. So 5 into negative 4 is negative 20, 20 into negative 3 is negative 60, 30 into negative 2 is negative 60, and so on. So multiply these values and you will get these answers. If you get these answers, then your answers are right. And next we need to make a total of these values, because these values will be used for the calculation of mean. So the total of FD row is 3. So 3 will be used in the mean. Next, I need to calculate FD square. Just like FX and FX square, FD and FD squares. FD and FD square both will be used for the calculation of standard deviation. How to do that? FD will be multiplied with D. So negative 20 into negative 4 is 80. Negative 60 into negative 3 is 180. Negative 60 into negative 2 is 120. So similarly, you can get all the values for FD square too. So don't make a mistake here. Use your calculus properly and get the correct answers. The total here will be 823. So these values will be used for standard deviation. Now for the calculation of median, you need a cumulative frequency. So in advance I am preparing all the columns here, so while calculating the measures I will not have to just go back and prepare new columns for that. So FD is for mean, FD and FD square are for standard deviation, CF is for median. How to calculate CF? The first frequency is 5 plus 20 25 plus 30 55 plus 47 102 plus 56 158 plus 56 214 plus 37 251 plus 16 267 plus 3 270. Now using all this data I am going to start with the calculation of my mean. A plus summation FD upon N into C. Now A is 14, FD is 3, N is 270 and C is zero point 0.5. So when I solve this data I get 14.01 inches. So average is 14.01. Next I need to calculate median. Now median is the value of n plus 1 upon 2 observation. So n is 270 plus 1 is 271. So 271 upon 2 observation makes it 135.5th observation. So from CF if you check 135.5th observation it falls under 158 and the observation in front of 158 is 14.0. So the median value is 14.0 inches or just 14 inches. I hope you guys have not forgotten. In case you don't remember it, just go back to the third chapter and check out the method of calculating median. It has not been that long since I taught you guys this. Next is standard deviation, the shortcut method. Summation FD square upon N minus summation FD upon N the whole square root into C. Now FD square is 823, N is 270 minus FD is 3 upon 270 the whole square the whole root into zero point 0.5. 823 upon 270 is 3.05, whereas 3 upon 270 and then whole square is 0.000121. When you find the difference it gets 3.049879. Then get the square root first and then multiply it with 0.5 and you will get your answer 0.87 inches. So the standard deviation of the shoulder length of t-shirts is 0.87 inches. Now we find the coefficient of skewness, that is the formula here is the alternate formula. J is equal to 3 times x bar minus median upon s. So 3 times 14.01 minus 14 upon 0.87. 14.01 minus 14 is 0.01. 3 times will make it 0.03 divided by 0.87 and the answer here will be 0.034. So the coefficient of skewness is very much near to zero. That is, it is very much near to symmetry and it is positive. So there is a positive skewness of very low degree. That is, when the skewness is near to zero, it is called to be near to symmetry. So this data is very much near to symmetry with a positive skewness. Moving on to the third question. The third question is the following distribution is obtained from the time taken in minutes by each worker to carry out a certain job. Find Karl Pearson's coefficient of skewness and interpret it. Okay, so what we need to do here is find Karl Pearson's coefficient of skewness and then interpret it. Now, the data given here is time taken in minutes and number of workers is frequency. Now the time taken is 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 29 and total. From these classes we can see that this is a continuous frequency distribution which is inclusive but all the class lengths are equal. Now maybe looking at frequency we will be sure about which method to use. Looking at the frequency we can see that there is only one maximum frequency. So naturally we can calculate mode for this data. We don't have to calculate median right now. To calculate mean we need to find the mid value, then use the D method because the class lengths are equal. So first of all I will go with the mid value here, which is 5 to 9. The mid value is 7, then 12, then 17, then 22, then 27. Next I have to calculate D. So D will be x minus the middlemost mid value 17 divided by the equal class length 5. So 7 minus 71 upon 5 will be negative 2. Similarly negative 1, 0, 1, 2. Okay, if I am assuming 17 as my assumed mean, then the D will be 0 there. The previous values will go negative, the next values will be positive if you want to do it like that. Then you multiply d with the frequency here, which is 3. So fd, so 3 into negative 2, negative 6, 8 into negative 1, negative 8, 4 0 0, 2 ones are 2, 1 twos are 2. So when you make a total here, you will naturally get a negative 10 answer. And next it will be fd square, because to calculate standard deviation you need this. So again you multiplied fd with d. So 6 twos are 12, 8 ones are 8, 0 0 0, 2 ones are 2, 2 twos are 4. And when you make a total, you get 26. You need to calculate mean first. So 17 plus negative 10 upon 18 into 5. First solve this negative 10 into 5 upon 18, and then because it is negative 10, you will subtract the answer from 17 and you will get 14.22 minutes. So the average time taken to complete a job is 14.22 minutes. Next, you calculate the model class, because you need to calculate mode for the continuous data. The model class is the class with the highest frequency. The highest frequency is 8. So class is 10 to 14, but that class is an inclusive class. So we need to convert this inclusive class into an exclusive class by deducting zero point 0.5 in the 10 and adding zero point 0.5 in the 14. So the exclusive class from this inclusive class will be 9.5 to 14.5. You need to write down the lower limit, that is 9.5, the model frequency 8, frequency before this 3, frequency after this 4, and the class length 5. So the formula which you are going to use here for the mode is L plus Fm minus F1 upon 2Fm minus F1 minus F2 into C. All of these things have been explained in the third chapter tutorials. Just refer to them if you have any confusions. Put the values here. 9.5 plus 8 minus 3 upon 8 to the 16 minus 3 minus 4 into 5. And when you solve this, you get 9.5 plus 2.78, that is 12.28 minutes. So the model number of minutes are 12.28 minutes. Next, we have to calculate the standard deviation. Now standard deviation is calculated using the same formula, summation fd square upon n minus summation fd upon n the whole square whole root into c. Put the values there. 26 upon 18 minus negative 10 upon 18 the whole square whole root into 5. 26 upon 18 is 1.4444. Negative 10 upon 18 the whole square is 0.3086 the whole root into 5. First find the difference and then make a root and then multiply it with 5. You get 5.33 minutes. So the mean is 14.22 minutes, the mode is 12.28 minutes, and standard deviation is 5.33 minutes. We will use all of these three measures to calculate coefficient of skewness. Coefficient of skewness is J is equal to x bar minus mo upon s, which is 4.2 over 14.22 minus 12.28 upon 5.33, which is 1.94 upon 5.33, which is 0.36. Because it's a coefficient measure, no units of measurement are there. If we want to write a statement from the data, we can say there is a lower degree of positive skewness in this distribution because the value is positive and it is near to 0. 0.36 is near to 0. So there is a low degree of skewness, and because it's a positive, it is a lower degree of positive skewness. We will move forward with the last question of this tutorial. In this tutorial, I am not going to complete the exercise because the exercise has a 7 questions with long answers. I am only going to do 4 sums in this particular video, and the remaining sums I will cover in my next video. Fourth question. The students of 11th have collected the data about profits in crore rupees of IT companies. Find Karl Pearson's coefficient of skewness and interpret it. Interpretation is the statement which we have written in the previous slide just now. So you have to write a statement like that. The profits in crore rupees, 5 to 7, 7 to 9, 9 to 11, 11 to 13, 13 to 15, 15 to 17, and total. As you can see from the table, the classes are equal and they are exclusive already. Next, we have the number of companies frequency, that is 5, 12, 28, 3, 2, total 50 companies. As you can see here, there is only one highest frequency and we can calculate mode. So just like the previous sum, we are going to calculate the same number of columns, that is mid value x. 5 to 7 mid value is 6, 7 to 9 mid value is 8, 9 to 11 mid value is 10, and 12, 14, 16. Next we have to calculate d. Now d here will be x minus 10 upon 2. You can just take any mid value from the calculation. I am taking 10 here. So 2 is the class length. As you can see, all the mid values have the similar difference of 2. So I am taking 2 in the division. So 6 minus 10 upon 2 is negative 2. 8 minus 10 upon 2 is negative 1. 10 minus 10 is obviously 0, 1, 2 and 3. You will get these answers. You don't need to make a total of this because we need to multiply d with the frequency here. So that is fd. 5 into negative 2 is 10, 12 into negative 1 is negative 12, 20 into 0 is 0, 8 ones are 8, 3 twos are 6 and 3 twos are 6. When you make a total you get negative 2 here. Next multiply fd with d. So negative 10 into negative 2 is 20, negative 12 into negative 1 is 12, 0 into 0 is 0, 8 into 1 is 8, 6 into 2 is 12, 6 into 3 is 18, and when you make a total of this you get 70. Now doing the similar things which we did in my previous sum, a is 10, summation fd is negative 2 upon n is 50 into 2. So your answer here is 9.92 crore rupees. Next, we have to calculate model class, which is the highest frequency 20 and the class is 9 to 11. So lower limit of the class is 9, frequency model frequency 20, before 12, after frequency 8 and the class length 2. The mode is L plus Fm minus F1 upon 2Fm minus F1 minus F2 into C. Putting the values in the equation and then solving 20 minus 12 upon 40 minus 12 minus 8 into 2, you get 9 plus 0.8, which is 9.8 crore rupees. So the model profit is 9.8 crore rupees and the average profit is 9.92 crore rupees. Next, we have to calculate the standard deviation using the same formula, putting the values 70 upon 50 minus negative 2 upon 50 whole square whole root into 2. When you solve this, you get 1.4 minus 0.0016 whole root. The difference is 1.3984 root, which is 1.1825 into 2 will be 2.37 crores. So using these three measures, we will calculate coefficient of skewness. Coefficient of skewness, which is j x bar minus mo upon s. Putting the values 9.92 minus 9.8 upon 2.37, which is 0.12 upon 2.37, which is 0.05. As you can see, this value is very much small, very much near to 0, and it is positive. So from the data we can say there is a very low degree of positive skewness in this distribution as the value is positive and near to 0. So my dear students, I will end my today's tutorial here. Next time I will be explaining the remaining sums of this exercise. So stay tuned for that. If you like this video, push the like button. If you have not, subscribe my channel and share this video with your friends. If you have anything to tell me, comment in the section below. Thank you very much and I will see you in my next video. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.